So here we're going to be talking about determining factors and zeros of polynomial functions. Okay, so take a look at number 29. It says, determine all the factors of this expression if one of the factors is 2x minus 3. Okay, now usually when it asks you to determine all the factors, normally what I would do first is I'd say, look at this, we have 4 terms, right? Let me try grouping. So if you group together the first 2 terms and group together the last 2 terms, well, out of the first 2 terms, we could pull out a 2x squared, which is going to leave me with 4x minus 25. Now, out of the last 2 terms, the only thing I could pull out would be what, a 1? So if I pull out a positive 1, it does not leave me with the same thing in parentheses as we were left with here. And we want to, in order to do factor by grouping, you have to be left with the same thing. So unfortunately, we're not going to be able to use the grouping technique to factor this. So that's why they give us one of the factors, okay? Since they tell us that 2x minus 3 is a factor, doesn't that mean that 2x minus 3 has to divide evenly into this expression? Okay, so let's put that in our notes just so we have that down. Since 2x minus 3 is a factor, it will divide evenly into our expression. Okay, so let's do that. Let's use long division and let's divide this expression by 2x minus 3. And when we do, whatever we're left with should be the other factor. Okay, so I know you guys are all pros at long division, so I'm going to kind of, go through this quickly. So when we do long division, we want to look at the first term out here. We want to look at the first term under the division bar and say, well, what do I multiply 2x by to give me 8x cubed? Well, I multiply it by 4x squared. So I'm going to put that on top of the division bar. And then we're going to distribute. 4x squared times 2x is 8x cubed. And then 4x squared times negative 3 is negative 12x squared. Okay, so we're going to change our signs, right? We wait till we finish distributing to change. So I'm going to change this to subtraction and circle it to show I changed it. And when you change this to addition, circle that to show you changed it as well. Okay, so the first 2 terms cancel, and then negative 50x squared plus 12x squared is going to be negative 38x squared. And let's bring down the next term, the positive 47x. Okay, so let's start the process again. What do we multiply 2x by to give us negative 38x squared? So negative 19x. So I'm going to put that up here. And then distribute. Negative 19x times 2x is negative 38x squared. And then negative 19x times negative 3 would be what? Positive 57x. Okay, so we're going to change this to addition and circle it, and we're going to change this to subtraction and circle it. Okay, so the first 2 terms cancel. And then 47x minus 57x would be negative 10x. And we're going to bring down our last term, the plus 15. And this should be our last step. And remember, there should not be a remainder. If 2x minus 3 is a factor of this expression, it should divide evenly into it. So if we wind up with a remainder, I got to go back and find the mistake. Okay, so we're going to say, what do I multiply 2x by to give me negative 10x? So just negative 5. So we're going to put that up here, and when we distribute the negative 5 times 2x is negative 10x, and negative 5 times negative 3 is positive 15. And then to show we're subtracting, we're going to change our sign and circle, change our sign and circle. And look at that, everything cancels. So we know we divided properly because we wound up with no remainder. Now, since this expression divided by 2x minus 3 gives us this answer on top here, doesn't that mean that this answer on top times 2x minus 3 would give us the original expression? So since this times this multiplies to give us this original expression, it means that these are our factors. And isn't that what they wanted us to do? They wanted us to determine our factors. Okay, so our first factor is 2x minus 3. And our next factor is 4x squared minus 19x minus 5. And the only thing we want to do at this point is we want to figure out, does this factor further? Now, this is not going to factor further, but if we look at this trinomial, right, because we have a number other than 1 in front of the x squared, we want to try out the rainbow. So basically, we multiply together the first and last term, right, and that gives us negative 20. And as long as we can come up with two numbers that multiply to negative 20 and add to negative 19, we can factor this further. And I definitely can come up with two numbers that do that. So what I'm going to do is, let's bring down the 4x squared, leave a big space, and bring down that last term. Okay, now, two numbers that multiply to negative 20 and add to negative 19 would be negative 20 and positive 1. So I'm going to put in the middle here a negative 20x and a positive 1x, which I'm just going to write as x. Now, this 2x minus 3 is still one of our factors, and they want us to determine all the factors, so I'm going to keep bringing that down. If they said determine all remaining factors, then you wouldn't have to bring this down. But because it says determine all the factors, right, we got to keep that as one of our factors. All right, so I'm just going to put a little line here to separate this. I'm going to keep bringing down the 2x minus 3. And let's factor what's in the parentheses here further. So since we have 4 terms, we're going to do grouping. So when I group together the first 2 terms, it looks like I could pull out a 4x, which leaves me with x minus 5. Out of the next 2 terms, the only thing I could pull out is a positive 1 or a negative 1, but in order to be left with an x minus 5 in parentheses, I'm pulling out a positive 1. Okay, which also leaves me with x minus 5. Okay, double close those parentheses. Okay, so we're going to bring down the 2x minus 3. That's our first factor. Okay, now our next factor is formed by taking the 4x and the minus 1, right? Those 2 terms that are in front of our common parentheses, and grouping them together as a factor. And then our final factor is this common, the common expression within the parentheses, so the x minus 5. So these right here are the 3 factors of this original expression. If I multiplied all these out and combined my like terms, I would wind up with this expression. So box off the final answer, or circle it, whatever you like to do. Okay, let's take a look at number 30 as well. So they give us f of x, and the first thing I want us to do is evaluate f of negative 3. So all they're looking for you to do is substitute all of the x's with negative 3's. Okay, so you could see here that I just basically took all of the x's from above and replaced them with negative 3's in parentheses. Okay, so you could either figure this out by hand, or let me just remind you how we can do this in our calculator. Okay, so basically what we could do is we could type in negative 3 and hit store. Remember, it's that button above the on, and then x, and then enter. So whenever I'm typing in a negative 3 in my calculator, okay, it's represented by negative 3. So now, let's just type in that original expression that was given to us. Okay, so there we go. And when I hit enter, it gives me 0. So what that means is when I plug negative 3 in for all the x's, this expression here is equal to 0. So that's the answer for the first part. Okay, my 0 kind of looks like a 6. I'm just going to make that a little better. Okay, so that is 0. Okay. Now, part B says, explain what your answer to part A tells you about x plus 3 as a factor. Okay, well, doesn't the remainder theorem say that basically, instead of dividing by x plus 3, if we substitute in negative 3, whatever the answer is would be the remainder. So because we would have a remainder of 0, that means that x plus 3 would divide into it evenly, so x plus 3 is a factor. So basically, in other words, x plus 3 is a factor because f of negative 3 equals 0. All right, so there we go. Okay, now it says to algebraically determine the remaining zeros. Okay, so if we want to find the remaining zeros, basically we just have to find the remaining factors, right? And then we could set those equal to 0 and make a t-chart and solve. Okay, so basically, since we know that x plus 3 is a factor, doesn't that mean that it divides evenly into our original expression? Okay, so let's do long division, and since x plus 3 divides evenly into it, we should wind up with no remainder. Okay, so here we go. What do we multiply x by to give us 3x cubed? Well, 3x squared, so that's what we're going to put on top here. And then when we distribute, 3x squared times x is 3x cubed, and 3x squared times 3 is 9x squared. And then we're going to change our sign. So change to subtraction and circle it, change to subtraction and circle it. Okay, so those cancel off. So negative 5x squared minus 9x squared would be negative 14x squared. And let's bring down the next term. And let's start the process again. What do we multiply x by to give us negative 14x squared? Negative 14x. So that's what goes on top here. So then negative 14x times x is negative 14x squared. And then negative 14x times positive 3 would be negative 42x. So we're going to change our sign and circle, change our sign and circle. All right, so these cancel off. And then when I combine like terms, negative 47x plus 42x is negative 5x. And let's bring down the negative 15. And the last step of this, what do we multiply x by to give us negative 5x? Negative 5. So then negative 5 times x is negative 5x. And then negative 5 times 3 is negative 15. And look at this, when we change our signs, this works out perfect, okay? Everything cancels, and that's exactly what we wanted to happen. Now, basically they want us to find the remaining zeros. Okay, so what we know at this point, we know that x plus 3 is one of our factors, and this quotient on top here is another factor, although it looks like this can be factored further. So let me just write this up. We know that, I'm going to just change color so everything doesn't blend in. We know that x plus 3 is one of our factors, and we know that 3x squared minus 14x minus 5 is another factor. Now, they don't want us to find the factors, they want us to find the zeros. So if we want to find the zeros, we need to set this equal to 0. And we need to solve. Okay, so basically, let's see, I'm going to move this over a little just to give myself a little more room. I'm going to bring the x plus 3 down. And then I'm going to factor what's in these parentheses further. Now, because we have a number other than 1 in front of the x squared, we're going to have to do the rainbow. And remember, when you do the rainbow, you bring down the first term, you bring down the last term, and we need to come up with two numbers that multiply to negative 15 and add to negative 14. So negative 15 and positive 1. And we have to attach x's to those. And you could put them in either order, it doesn't matter. Okay, so I'm going to bring down this x plus 3. And let's factor this further. So out of the first two terms, I could pull out a 3x, which leaves me with x minus 5. Out of the last two terms, I could pull out a positive 1, which also leaves me with x minus 5. And make sure you keep bringing down the equals 0, right? You want to keep it in an equation. All right, so we have x plus 3 times, and I'm going to group together this 3x plus 1. And then I'm going to rewrite this common parenthesis of x minus 5. Okay, and because it says equals 0, we need to make a t-chart and solve. So If you do take each of these factors, I'm going to do it the long way, and set them equal to 0, all we have to do is solve these three equations. Okay, so the first equation, we would subtract 3 from both sides, leaving us with x equals -3. Okay, the next one, we have to subtract 1, giving us 3x equals -1. And then when we divide by 3, that's a negative sign, we get x equals -1/3. And then over here, we're going to add 5 to both sides, giving us x equals 5. So these three numbers here, -3, -1/3, and +5, are the zeros of our function. If we substitute them in for x, right, this function would be equal to 0. If we were to graph this function, this is where our graph would cross through the x-axis. Now, be careful, because this word right here makes it tricky. They don't say determine all the zeros, right? We already found that f of -3 is equal to 0. We found that in the first spot. So basically, what we need to do is we only need to circle the remaining zeros, okay? So x equals -1/3 and x equals 5.